Right, so we need to get 1 degree of freedom at least, which means we need to see if we can ask M+ for fewer things. So we will have to revise the model. Perhaps we can take a path out to release 1 degree of freedom, but which path should we take out? So have a look at these model results. In fact, why don't we have a look at the standardized results? And have a little think, which one would you suggest we take out? So in general, the strategy was you take out a pathway that was not significant, so presumably either this or this. But you make sure the theory allows for it. Another rule of thumb is that you should only take out 1 path at a time. The same procedure goes with adding paths. You should only add paths in 1 at a time. There is, however, another general rule, which is in SEM we prefer models that are more parsimonious. In fact, when you look at the model fit indices, 2 of them are quite heavily weighted by parsimony. So the RMSEA and the TLI will quite heavily penalize models that are too complex. So in general, if you have a good CFI and a rubbish TLI, it could be that you have pathways in your model that are not significant, and these are affecting your TLI value. So quite often, what researchers end up doing is they end up taking out all of the non-significant pathways one by one until they have a submodel with only significant paths in. But like I said before, this should be theory-driven, and sometimes you might actually want to make a point that it is one predictor that is significant, but not another. So in those cases, you might want to keep a non-significant path in to make that point. So in sum, you would prefer to have more parsimonious models, and in general, most people take out all non-significant pathways. The standard procedure is to take them out one by one. That's because every time you rerun a model, everything is re-estimated from scratch. So anything could change when you modify a path. However, you should always keep theory in mind. Now, having said this, I'm going to go ahead and delete both of the non-significant pathways at once. So I'm already breaking my rules. So I guess I'll just be a bit naughty and do them both in one step, which is not something I recommend, but because I know where this is headed, and I've done this model before, I think it is nice for you to see the final model and not all the intermediary models. So let me go back to the M+ input file and do it there. So the parts I'm going to take out are that from conflict to child externalizing problems and the one from conflict to perceived parenting competence. Right, so here we are. We want to take out those 2 paths. So child on conflict, and instead of deleting it, I'm just going to put a little exclamation mark in front. Maybe I'll even make a little note here to say not significant. So you see now that this entire statement is highlighted in green, so M+ doesn't see it anymore. It's invisible. The other one I wanted to take out was this one, from conflict to perceived parenting competence. So I'm going to do the same with this and make a little comment here, not sig. And then I'll just run the model again. So let me scroll down straight to the model fit. And I'm going to save the model fit and the model results again in a separate file so we can annotate it. So I opened it straight to the model fit information, and the first thing to note is that above this section of the output file you get this thing here, model estimation terminated normally. Do you remember what else you could get here? We were saying before that this is something you really want to get. If you don't get this, you will have gotten either a warning or an error, and that warning or error will be with regard to your analysis, and that's something you really don't want to get. So getting this is fantastic news. Now have a look at the model fit indicators. The ones you are looking for are the chi-square, the RMSEA, CFI, and SRMR, and of course the TLI alongside the CFI. So have a go and have a little think. Do you think our model fits the data well or not? Excellent. Indeed, the model fits the data very well. Let's have a little recap. We want the chi-square to be as close to 0 as possible, and we would like the p-value to be not significant. So tick and tick. We also have a positive number of degrees of freedom, which means these numbers, whatever numbers you get, are real. Of course, if we had 0 degrees of freedom, the chi-square would have been 0, and its p-value would have been 0 as well. Then for the RMSEA, we would like it to be below 0.06, or at least below 0.08. Ours is below 0.06, which is very good. In fact, the probability that the RMSEA value itself is below 0.05 is quite high. Now the RMSEA comes with a confidence interval, which tells us how confident we should be in terms of the actual coefficient here. So this is the confidence interval, and it has a lower bound and an upper bound. Ideally, you would want these to be quite close together because that means there's a lot of precision in measuring that RMSEA coefficient. And also, you would probably very much like to have the upper bound be below 0.06 or at least below 0.08 because it means that the actual RMSEA estimate is definitely below those thresholds. So we get a further tick mark here. Now the CFI and TLI have the same thresholds and we would like them to be above 0.95 or at least above 0.90. In this case they both make those thresholds, so 2 tick marks here. And finally for the SRMR we would want that value to be below 0.08, which it is, so excellent. So all of our fit indicators meet the thresholds, which is wonderful. We have good model fit. Now let's look at the results. And I'm going to scroll down to the standardized solution. Why don't you have a go in trying to formulate what these numbers actually tell us in terms of effects and effect sizes? What's the story? So it looks like higher stress is related to higher perceived parenting incompetence, and also to heightened child externalizing problems. In addition, higher perceived parenting competence is related to heightened child externalizing problems. However, you can see that all the coefficients are actually pretty small. What about these two things here? What's the story told by these numbers? So, looking at this, you would say that a significant proportion of variance in both parenting competence and child externalizing problems were explained by the predictors. However, the actual proportion of the variance is really quite small, only 4.3% for parenting and only 8.2% for child externalizing problems. And you can see that also by looking at the residual variances. Because remember, the residual variance in standardized form is the opposite of the R-square. It's the proportion of variance that remains unexplained. What about indirect effects? You scroll down further and let's say we look at the standardized indirect effect, and you see it here, and it's significant. Now, we also have this other indirect effect here, which is 0 with a p-value of 1. That is because we have left it in the input file. Let me show you. So the reason that line appeared is because down here we still kept this path in. In fact, we really shouldn't have, because we no longer had one of the parts of the mediation. We didn't have the path that connected the mediator to the predictor. So in fact, we should have been quite careful and deleted this as well. And actually, because this is something that we should have done, taken it out, when you run the model and you get the output file opened on top of the input file, and you scroll down a little bit and see these warnings, you now have an extra warning that you didn't have before. It says there is an indirect effect involving a path between the following variables, but no indirect or direct path exists in the model. In addition, because the variable conflict is now disconnected from everything else, we have taken out both pathways that relate to conflict. We have yet another warning. It says at least one variable is uncorrelated with all other variables. Check that this is what is intended. So let's have a look at the diagram. As you can see, you now have this variable here, and it's just hanging out by itself. If you really trim your model in this way, then at this point you should seriously consider whether you want to still keep this variable in the model. In practice, you will probably never have to deal with this, with having a variable that's completely uncorrelated with everything else. That's because at the theory formulation level, you will have probably already selected things that in reality are related, and if your data is any good, then it probably will be related to something. But this would be a point at which, if you want to make that kind of modification, so to exclude a variable from the model altogether, you should realize that that's a major revision of the theory. Your model becomes highly exploratory. So in sum, when you revise a model, you should always keep in mind that you are stepping out of a confirmatory framework into an exploratory framework. And you should always be very transparent about it, because every time you do it, and the more modifications you make, you are now relying more on a model that is data-driven rather than theory-driven. The major implication is that your model is more susceptible to peculiarities of your own dataset, and therefore your results are less likely to be generalizable. Now, I suppose that most often you will end up having a revised model, and you will not end up publishing the first model you tried. But it is best, like I said, to be transparent and note that in the paper, and try to make as few modifications as possible, while keeping in mind that we do prefer models that are more parsimonious. So this is it. You have done your first path analysis. Well done.